or a lawyer when you grow up? But sometimes you wonder, why do I have to learn math at a school? If so, this video is for you. Hi, I'm Miss Marilu, and this is Mathematicians in Action. The purpose of learning math is not just to pass a test to move to the next grade level. For sure, it's not to make your day harder or boring at school. The reality is that math is essential to understanding the world around us. And we need math to successfully accomplish even the most basic tasks in our everyday life. And did you know that most professions use math to successfully accomplish their job? For example, numbers provide an abundance of information for medical professionals like doctors, nurses, and veterinarians. They're constantly using math to write prescriptions or to administer the right amount of medication. Police officers also use math in many ways. A few examples are when they have to analyze traffic accidents to determine the cause of the accident and the cause of victims' injuries. They also need math to write tickets. For example, in some places, the faster a person drives, the more the ticket will be if they get caught. And this is determined by using a mathematical formula. Another example are firefighters. They use math to calculate the nozzle pressure and how much water they will need to put out the fire. Scientists are always using math. Any modern science like biology, chemistry, psychology, geology, and physics relies on graph, statistics, and mathematical calculations. Hi! Did you also know that pilots and astronauts are constantly solving mathematical equations to pilot the craft? And these are just a few examples. The truth is that learning and practicing math train our brains to think logically, to recognize patterns, to identify and state a problem clearly, and to find ways to solve the problem. I know, learning math can be challenging sometimes, but remember, it gets easier with practice and a positive attitude. Thank you for watching. Don't forget to subscribe and leave your comments below. Bye-bye.
Hello. Welcome to the live. And we have with us here our Professor Mahesh, and we have Mr. Sanjay. I want to welcome you today to this interesting webinar and discussion. And Professor have done a lot of stuff.
There's a background noise. Hello.
Hello.
All right. Please, I don't know. I'm getting that noise too. All right. Thank you very much. So, in a brief, we are going to have Mr. The profile and Mr. Sanjay.
All right. Thank you very much, Ms. Davids. I'll start with the profile for Professor Mahesh Sharma. Professor Mahesh Sharma is the founder and president of the Center for Teaching and Learning of Mathematics, Inc., Wellesley, Framingham, Massachusetts, and Berkshire in England. Berkshire Mathematics facilitates his work in the UK and Europe. He is the former president and professor of mathematics education at Cambridge College, where for more than 35 years, he taught mathematics and mathematics education to undergraduate and graduate students. He's internationally known for his groundbreaking work in helping understanding mathematics learning problems, and their diagnosis and remediation, particularly dyscalculia and other specific learning disabilities in mathematics. Professor Sharma provides direct services of evaluation and tutoring for students, children as well as adults who have learning disabilities such as dyscalculia or face difficulties in learning mathematics. He works with teachers and school administrators in the US, Europe, and Asia to design strategies to improve mathematics curriculum and instruction for all. He also offers regular workshops and lectures for teachers, special educators, administrators, and parents on mathematics education, learning problems in mathematics, including dyscalculia, teacher training, and mathematics curriculum development every month at the Framingham State University. He has been helping many school systems and organizations throughout the USA to effectively implement the Common Core State Standards in Mathematics, CCSSM, at all grade levels. He writes a regular blog on topics on mathematics learning, education, learning problems, and dyscalculia, and mathematics as a language. The blog has readership in more than 125 countries. At Ziva Birthing and Early Years Educators Africa, we're so delighted to partner with Professor Mahesh Sharma and his organization. You're welcome once again, Professor.
Thank you. Thank you. I'm very happy to be with you.
Thank you
Very
much.
happy to participate where mathematics learning and teaching is being emphasized and being brought to a larger audience. And the video actually explained why children from the very beginning must be taught in such a way that they do not feel as if mathematics is not possible for them to learn. As a matter of fact, when we think of mathematics learning, it is the early childhood mathematics learning, which is the foundation stone for future mathematics learning. If I may, I would like to take a parallel between reading, literacy, and numeracy. Almost all mothers and fathers read to their children from the very beginning. They even read when the children are 6 months old, 8 months old, 1 year old. So when children come to school, they have a vast reservoir of sound, word, language, and therefore they are ready to do the written part of the new literacy. Now that is the foundation. Now, if we look at it in a formal way about literacy, if a child knows his letters, whatever the native language of that child might be, if the child, for example, in English, they have a good sight vocabulary, if they have good phonemic awareness, and if they have word attack skills, they are not afraid of attacking a new word because they have the sight vocabulary, phonemic awareness, and how to decode that word. Now, if there is a sympathetic, knowledgeable adult and practices those skills, the child becomes a reader. And the whole world is open to that child. The whole learning, whole world becomes something which he can aspire to. Now, that is what we do already. That's what most teachers are good at. Now, we take the same thing about numeracy. In numeracy, the fundamental things are the same. If a child knows number, which is the alphabet of mathematics, actually only 10 numbers, the 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If a child really understands those 10 digits well, and then the child has good sight vocabulary in mathematics, which we call as sight facts. That means, for example, if I know this card, can you see this one?
Not really.
Card here.
Yeah.
When I see this card, right away, I see that there is a 3 and there is a 2 And if I knew this card is 5, then I'll say 3 and 2 is 5. 2 and 3 is 5. And if I tell the child, what if I did not have this one? Then what will be this number? Oh, 4. Now, why am I taking 5? Because every child has a skill, which we call as cubitising, innate skill, which is hardwired. Every child is able to recognize a collection of objects up to 5 or 6 innately. And it's possible because in evolution, the child's mind is developed to see a group of objects and make behavior. For example, for an animal, if there are many animals, then he takes strategies. So that is an evolutionary process. So if the child is able to recognize a collection instantly, up to 5 or 6, then that child is ready to learn the side facts. For example, if I look at this card, then I was, oh, there's a 2 and there's a 1, and 2 and 1 is 3. Notice I did not count. So number is not learned by counting. Number is learned by looking at patterns, looking at arrangements. In the video, it was mentioned, mathematics is not counting. Mathematics is a study of patterns. When a child recognizes a pattern, then that child is ready for any kind of mathematics. Now here, the same number 3 is organized a little differently. And when we see the 3 in this way, and then now I can clearly see 2 and 1. And when I compare it with that 5, then right away I can see, when I compare these two numbers, I'll say, well, that's 3 on the top, and this 3 on the top are the same. And if there's any difficulty, I can put it like that. So I can say the 3 on this card in the bottom, and 3 in this card on the top. Then we are able to see which number is bigger, which number is smaller. So the first element of learning a number concept is the ability to recognize a collection by sight, by looking at it, and know what number it represents. Then we have a fundamental skill in mathematics, which we call decomposition recomposition. Now we saw number 5, and if I take a bigger number and then I compare with that one. So for example, if I take this one, then I'll say, do you see a 5? Do you see a 5? And then 5 and 5 is this number. So this decomposition recomposition is the basis of learning addition and subtraction facts. By doing so, we have given a child an ability to make sense of number. So knowing the 10 numbers, recognizing side effects, decomposition, that gives a child skills of attacking numbers. And therefore, numbers are within the reach of that child. Now, when we're teaching children, from the very beginning, we have to focus on that it is not the counting, but it's seeing the number relationship. And good learning, effective learning, is dependent on effective, efficient materials, instruction materials. For example, if I look at another material, there's something called Cuisenaire rod. The Cuisenaire rods are representation of numbers in length. When I look at it, this is called the 6 rod. This is called the 10 rod. And right away, when I put them next to each other, I can see that the 10 is longer than 6. 10 is more than 6. 6 is less than 10. And then if I take this 4 rod and then I say, look at it. Now I can see that 4 plus 6 is 10. 6 plus 4 is 10. 10 number is 4. 10 is 4 plus 6. By this, we are able to bypass the counting process by which the number are learned by most children. In learning mathematics, number concept is the first fundamental developmental milestone. Similar to number concept, there are other milestones: number relationships, place value, fractions, integers, and so on. But all of them are dependent on strong number concept. And when the strong number concept is there, children have ability to recognize the number effectively, relationship between numbers, and then operations on numbers. Let me give you an example. When I see this card, and we saw the 5 card a moment ago, and by looking at this card, in few exposures, the child realizes that 5 plus 2 is 10, 6 plus 1 is 7, 5 plus 2 is 7, 4 plus 3 is 7, 3 plus 4 is 7. This ability to decompose, recompose, just like phonemic awareness in literacy, is fundamental. Most children have difficulty in learning facts, whether it's addition facts or multiplication facts, because our strategies are based on number counting. But if our strategies are based on clusters, patterns, relationship of numbers, then they are able to learn those very easily. To give you an example, suppose I take these 2 rods. Now at present, this is yellow, which is number 5. This is purple, which is number 4. And this is yellow, which is number 5. So if I read it, I will say 5 plus 4. And then I can say that's the same thing as 4 plus 5. That means without counting, I know that 4 plus 5 will be same thing as 5 plus 4. As a matter of fact, if I put this blue rod on top of that, which happens to be number 9, then we can read this as 9 is 5 plus 4. 9 is 4 plus 5. 4 plus 5 is 9. 5 plus 4 is 9. 9 is equal to 5 plus 4. As a matter of fact, if I remove this 5 rod and I ask a child, what was the rod there? Oh, the rod was 5. So what number is missing? 5. So what number plus 4 will be 9? And by remembering the color and the number, the child is able to see that relationship easily. This brings to me a very important idea behind learning. When we are teaching children, it is not the content only we are teaching to children. We are also making them better learners so that they are not defeated by a difficult problem. When we think of making children better learners, there's a concept called, which deals with executive function. As a learner, we are not just using what we see, but we are also using the cognitive functions. Executive functions deal with 4 major skills. First one is called the working memory. Second one is called inhibitory control. That means able to focus. Number 3 is organization. And number 4 is flexibility of thought. Now, to invoke, develop, effectively use working memory, our materials must be such that they leave an impression on my working memory. So a moment ago, I made an equation. There was a yellow rod. There was a purple rod. There was a blue rod. And with very little experience, I will know what those numbers are. But since that color was there, I have an impression on my working memory. And therefore, I can visualize that equation. And I will say, yes, there was a yellow rod, there was a purple rod, there was a blue rod. So yellow plus purple equals blue. but I happen to know the numbers. 5 plus 4 equals 9, 4 plus 5 equals 9, 9 equals 5 plus 4. All of this is going on in my working memory. Anything I can hold in my working memory goes to long-term memory. So if the material we are using is effective, is efficient, then we are able to transfer that information in the mind's eye. So working memory is an important part. The second was inhibitory control or focus. Now, I still have that image of those rods in my mind's eye. Therefore, my focus is there. Imagine compared to that, if I had 9 objects in a sequence, and I counted 1, 2, 3, 4, 5, and then 6, 7, 8, 9, I will not remember that in my mind's eye. And therefore, I will have to make more and more and more and more effort. And when I did make that many efforts, I begin to feel that the task is requiring more than what I really want to give to that task. And therefore, children begin to feel defeated about mathematics. I want to take another example of that working memory. Let's look at this card. Now, this card, there are 4 in the first column, 4 in the last column, 1 in the middle column. And with little experience, the child can say, oh, there's a 5 on the top. There's a 4 on the top. There's a cluster of 5. There's a cluster of 4. Now, if I say to the child, what if I hide that part? Tell me what is being hidden behind the card. And the child says, I think there are 2 missing. No, actually there are 4, because there were 4 in the first column and 4 were in the last column. Now I see only 2 in the first column. Now I see 2 in the last column. That means 2 are missing there, 2 are missing there, 4. All of this is taking place in the working memory. And since I'm holding that card is helping the child to focus, the second element of that executive function. Then the third element, organize. The number 9 is so nicely organized that I can create a picture of this in my mind's eye, the image of this in my mind's eye. And I'm able to decompose and recompose that 9 in the mind's eye. Not only that, that brings me to the fourth skill, which is flexibility of thought. Flexibility of thought means I can look at this 9 as made up of 3 and 6. I can look at this 9 as made up of 8 and 1. I can look at this 9 as making of 7 and 2. The cluster is showing me that it's made up. So all of those decomposition, recompositions are helping me to arrive at that 9 in so many ways. And that helps me in having efficient way of fluency in number concepts. So number, when it's taught in a systematic manner, and this can be done from age 3, and by the age 4 and 5, we have found that children have mastered the 45 side facts. Now, why am I saying 45 side facts? My research shows that as children who have a larger sight vocabulary and phonemic awareness, they become better readers earlier, quicker, with more competence, with better comprehension. Similarly, children who have started number concepts by knowing the sight facts and the decomposition, recomposition, they are better prepared for mastering addition, subtraction, multiplication, division facts. So when I showed you this number 9, I said 8 plus 1 is 9, first side fact. 1 plus 8 is second side fact. 7 plus 2, which is also on that number, is a third side fact. And similarly, 5 and 4, 4 and 5. So every number has 1 less than the number of side facts. So 9 has 8 side facts. 10 has 9 side facts. If I take the number 10, these 2 10 cards, and by the help of these 10 cards, I can see 8 plus 2 is 10. 6 plus 4 is 10. 5 plus 5 is 10. As you can see, if I cover this one, then I have 8 and 2 hiding. If I cover this, then I have 6 and 4 hiding. And by this, we can develop the side facts of each number. And when the side facts are there, the child can learn any number of addition, subtraction, multiplication, division facts. So I believe very strongly when the number concept is taught properly, and it can begin at age 3, and by age 3, 4, and 5, they are ready to tackle with any kind of mathematics if they know a strong foundation of number concept. I will take questions if there are any, or discussion. Otherwise, I don't want to make this as a lecture. I have lectured all my life, so I don't want to make this also as a lecture. I'd like to have some interaction from the panel or from the people who are, if they have access. Do you have some questions there? I'm not able to hear.
Are you hearing me now?
Yes.
Yeah, I say this is very interesting. I like that this is recorded so that we can send this to all of our parents to listen to. And if number is taught properly from the age of 3, there is a lot that the children can get from it. And it's good that we are starting at the age of 3, which is not common. I want to say a lot of children struggle, a lot of teachers struggle.
We start telling children the alphabets from age 2. As a matter of fact, even at age 1, I've seen parents telling that's called A, that's called B. Well, every culture has playing cards. Every culture has the dominoes, dice, and many other objects like that. So when children are exposed to patterns of numbers, clusters, and they are shown the relationship on those clusters, on those patterns, children begin to see the number relationships as early as they begin to see the alphabets and begin to see words.
So are there things in the environment that we can use as parents, before children begin school properly, to make maths interesting to children? Because sometimes children go to school and they found that maths is not very interesting. They don't get to enjoy maths. How can we make maths is very interesting, using household items for children?
Imagine for a moment, just imagine, the child never heard any words, did not have any language, and reached the school. And then we say, now we are going to teach literacy. You will face the same problem, that the child doesn't even know the letters, doesn't even know any sounds, doesn't even know any words. Well, we need to create in every home a culture where number is discussed in the same way as letters and words and sounds, and we tell stories to children. Well, there are number stories also. So we need to have a culture starting from the very beginning. We gave a set of cards and Cuisenaire rocks to a group of children between age 2, 3, and 4. And before, I just gave a set of Cuisenaire rods, and I said, arrange them any which way you want to. And about half an hour's time, 4-year-olds were able to organize them systematically from smallest to largest.
Wow.
And they were able to say, oh, look, this blue one is only one more than the brown one. And the brown one is only one more than the black one. I say, if black was 7 and brown was 8, what will you say? Well, then they will say 8 is one more than 7. So exposure, discussion, and asking questions. These are the elements by which the fear, the love of mathematics, fear can be reduced and love of mathematics can be developed in children. It's a question of exposing children to good patterns, relationships, and numbers.
Yes.
Wow.
Yes.
Interesting. I'm liking this, and I like that Professor have researched a lot about children with learning difficulty and how to support children at any age who sort of mirror their numbers and all of that. So before we come back to Professor, I know that Sanjay, you have been doing a lot of work with children over this period. And I would like Itoron to please, Mrs. Okide, kindly give us a brief profile of Sanjay, and then let's hear how his experience with children has been over this period.
Thank you very much, Ms. Davids. Before I make the introduction, I just like to make a comment on what Professor has said. I think that is very true, especially even in schools. As a school owner, we always make that mistake to start with numbers. What I'm saying now that is actually it's the best thing to start from concrete to abstract. Numbers are a bit abstract for the children. So when you bring things like those blocks and things, it's something more concrete and they can resonate with rather than just introducing numbers to the children initially to start, as is usually the practice that we've been doing. So I think I really agree with them. For literacy, we start by sounds, introduce sounds to them before actually introducing the alphabet sounds, maybe environmental sounds, animal sounds. But this is one tip I really learned over here, that you start with the concrete, which is the patterns, and before moving to the abstract, which is numbers. So thank you very much, Professor, for that.
Thank you.
So I'd like to welcome Mr. Sanjay. Thank you very much. Mr. Sanjay Raghav has an MSc in mathematics and an MA in education. He's always believed in making math learning engaging, effective, and conceptual accurate. He has mentored many students across different groups and has been continuously working to improve the teaching and learning for the children. He's also a consultant and advisor to the organization like Bluebell School International, Agagati Foundation. He has designed and offered courses on algebra and early numeracy in Ahmedabad University, Delhi. He has been the consultant for CECED and Language and Learning Foundation and designed manuals for teachers and workbooks for children. Presently, he's working with teachers, children, and parents in helping understand mathematics better and making it effective. His techniques and work with children offers insights into children thinking and suggests how we can help children to learn mathematics effectively. He's presently the Chief Operating Officer of Mathematics for ALL CTLM USA, founded by Professor Mahesh Sharma. Mr. Sanjay Raghav is also an adjunct faculty at the School of Education Studies, Ambedkar University, Delhi, where he teaches courses on algebra and geometry. We're so delighted to partner with Mr. Sanjay Raghav at Ziva Birthing as we support children optimally. So welcome again, Mr. Sanjay. It's lovely to have you here, and we're excited you're here with us today. Thank you very much.
You're muted.
I think we've lost the audio with Mr. Sanjay. So I don't know, maybe you can try and adjust the audio a bit. Can anyone hear Mr. Sanjay?
No.
No, can't hear Mr.
I think it's from
Sanjay.
your end then. Please help us rectify it. We can't hear you.
Try again.
Hello, Mr. Sanjay. Okay, maybe we can take some more questions while we wait for that, so we don't have too much of a time.
Am I audible?
Yes, you are.
Am I audible?
Yes, we can hear you better now.
Okay. Okay, is it fine? So thank you,
Yeah.
Vivian, and I did wonderful introduction.
Toro, can you just say
You
Toro?
can hear me?
Faintly, faintly. I can hear you faintly.
Okay, I'm trying to just give me a second. Can you hear me now?
Yes.
Much better.
Am I audible?
Yes.
Yes, you are.
Okay, there is lag that is there. Okay, this is better, I believe. Yes, so thank you for that wonderful introduction. And I want to share more than what I do with children. I would say that I've been with Professor Sharma for about a year. And I would say that this journey has been wonderful. And I'll share rather than saying what we are doing, I'll share an instance. So I was working on certain applications, designing applications for students. And I wanted Professor Sharma to give me some assistance on how to design those applications. And so when I was using them, I realized that children were not very attentive to that, and children were not engaged in that. So I called him up, and that's my usual routine. Whenever I'm stuck, I would call him. And I called him. I said,
Yeah,
Professor
finish.
Sharma, I'm facing some challenge.
He's
And
having this
am
program.
I
Oh, he's
uh, am I audible? Yeah.
Yes, you're audible. I
So
can hear you.
I would share that. Yeah. So I said, Professor Sharma, I'm facing some challenge there. And what should we do? Because I'm trying all sorts of applications to help our children. So he invited me to one of his classroom and online only, and he was working with a 5.5-year-old, and I was there observing this girl, and he was working with those rods that he has already shown you. So when this girl was working, and she was just 5.5-year-old, and can you imagine what she was doing? She was doing 23 times 24 or 15 times 17. And she had not just memorized those, but she would display whatever. She could demonstrate that. She could show you what 13 times 14 even looked like. And she was working with these blocks, Professor Sharma, and we also use these blocks. These are called Dean's block. So this is a hundreds block that we have. So he was using them. And after an hour, when the session was over, so I was more than mesmerized to see that. And I asked him, I said, Sir, I saw that engagement was good and it was so well. What were the reasons for that? I saw that, and I believe that I have to. There is something that I was missing, but I found some answer. Can you just elaborate on that a little more? So he shared with me that brain receives information through three inputs. One is auditory, one is tactile, and one is visual. And because these rods were arranged in patterns, they had color and they can be touched and felt and manipulated. So all those three were the inputs through which the information was coming. And through his questioning, he was helping them, helping this girl to form that concept. And that was the day when I realized that how important it is that the experiences, the tactile, the visual, and the auditory experiences, are so powerful in helping a child form the conceptual ideas, and our questioning and our where we want to have the child lead the child affects the learning. And that was the day I realized that okay, fine, I'm going to like work on this. And that was the day I would say that I saw so much difference in when I was working with children. So then we started working with parents now, and we've been mentoring parents, under Professor Sharma's guidance. And interesting thing that we have observed is that there are 4 years old. In fact, those who have turned 4 year olds just last month, and when they were shown some cards, they could compare those cards, and they would say, well, there is a 4 there, there is a 6 there, and 6 is 2 more than that, and 4 is 2 less than that. And these were just 3.5 or 3 years and 10 months. But they were able to do that so flexibly. So it gave us so much confidence that if used proper techniques, then every child can master that. And one of the things that we also noticed was that the input that the parent gave, the kind of interactions, the quality interactions that the parents were having with these children. So where children parents were more active with the children, we saw tremendous difference. In fact, some of the children who were as young as 4 years could sit in sessions for 2 hours
You.
coming up with ways, and Professor Sharma has been mentoring that, and we have seen some phenomenal results in how parents and students are responding to that, and the strategies we are using have been so effective that we have seen that they have really mastered these concepts, and they get so engaged that number concept becomes something which they are very confident with. And I believe, as Professor Sharma already said, that if the number confidence is really well formed in the mind of the child, then the later learning becomes very easy. So that's what I had to share.
Wow.
Thank you very much.
Wow, very good. How do you mentor teachers? Because this is huge. This research is huge. What have you made available to support teachers? Because not all teachers have this information and they don't sort of get it right. And we see a lot of children growing up not loving mathematics. And that is because from the beginning, they have not been taught well. I want to know more about your project, your center, and how you can spread this to Africa, to Nigeria, so that we can have more teachers who can begin to learn this construct, who can begin to learn this mode of operation and use it for our children. Can you tell us the success for your center and how it works, please?
So
It will be, yeah, sorry.
go ahead. Go ahead,
No, I
Sanjay.
was telling that Professor Sharma will be the right person. In fact, I wanted to share that only.
Okay.
So you start.
You see, teachers, I have found teachers as fantastic reading teachers, language teachers. They have such skills that they are able to mesmerize children by their stories, by their songs, by their interaction. So, to be an effective teacher in mathematics, you need three things. Number one, I must know the content of mathematics the children must learn. I must know the trajectory of the development of concepts. I must know what are the most effective materials, most effective strategies to help children to acquire those competencies. So that's the one element. Do I know number concept, how it develops in children, how it is conceptualized in children? And there's so much research now. We know so much about the mind, so much about the brain, so much about the number concept. The only thing which is missing is how do we bring this information to children? And the teacher is the link. So the first element is that teachers themselves have to feel that they really like number concept teaching or mathematics teaching. And they have to have become aware of that trajectory. Number two, they must know that instruction materials which are effective are those which have color, shape, size, strategies, and the ability to visualize. When I was hearing the summary of what I said earlier, you see, intuitive level of knowing something is first, and children already come with experiences, and that acts as intuitive level of knowing. Then we have to have effective concrete models. From concrete, we have to take them to pictorial. From pictorial, we have to take them to visualization. Can they visualize? The other day, I was working with a 6-year-old who was told by many others in diagnosis that he will never be able to learn the addition facts. And he has been struggling with the addition facts. So I said, I was using the rods and the cards. And I said, I want you to tell me 8 plus 6. And he started counting on his fingers. I said, wait a minute. How will you make that 8 as 10? And he said, well, I saw the 10 rod. It was 2 more than the 8 rod. So I will use 2. Then I said, how will you go from 10 to add the other number? What have you used from 6? And he said, I have used 2. So there's a 4 left. So I'm going to add that 4 to 10. So 8 plus 6 is 14. This decomposition, recomposition. So then I said, what do you think will be 48 plus 6? He said, I don't know. I said, well, how will you go from 48 to 50? And he said, 2 more. Where is the 2 coming from? From 6. What's left in 6? 4. So what will you do with that 4? Well, I'll add to that 50. It'll be 54. I said, what if you have 178 plus 6? Oh, that's a big number. I have to write it down. I'm a visual learner. I said, no, hold on. 178. Forget about that 170. Just think of that 8. Oh, that I can handle. How will you make that 8 plus 6? Oh, I take 2 from 6, give it to 8, that becomes 10. 4 are left in 6, that's 14. So the key element is questioning process. Teachers have to become better questioners. They must scaffold those questions. They must know where the child is and where he or she wants that child to be. And as we take a child on a trail to a summit of the mountain by showing, go there, and that is hard, and that's difficult, but we are going to go that way. We need to help guide the children by our questioning process. So trajectory of the concept, the good efficient models, good strategies, good questioning process, and love for children. Love for children is not enough, and mastery of content is not enough. The connecting these things are instructional materials. When teachers have good training, they have the integration of these 3 things, we'll be able to achieve that anywhere, whether it's a rural area, urban area, city area, in one country or the other. This is my very firm belief.
Okay. Hello, hello, Professor.
Yes.
Can you? All right. Miss Vivian has been logged off, so she will join us in a bit.
Okay. So
she's having a little bit of a network issue here. So just a question here: how do you assist children with difficulties, learning challenges, like in learning mathematics?
Well, first thing is, in the introduction, it was mentioned that many children or some children have dyscalculia. Real difficulty in mathematics, the percentage is about 6% of the general population. But the children who face difficulty or experience difficulty or are afraid of mathematics, that is called acquired dyscalculia. And acquired dyscalculia is the byproduct of inefficient teaching, inefficient instruction materials, inefficient practice, inefficient way of relating children to mathematics. So most of the problems are created problems by our environmental factors of poor teaching, poor standards, poor materials, and so on and so forth. So if children from the very beginning are introduced properly, the number of difficulties will be reduced. Now, if there are cognitive deficits, there are intellectual deficits, then teacher's role is twofold. My role as a teacher, my role as a tutor is twofold: to help the content, but also help a child to become a better learner, improving their executive function, improving their learnability. And modern research in neurology shows that brain is very plastic. It changes. I have worked with children who were not able to see many things. But when we design activities which are more effective, they are able to engage in them and they are better learners. And all of a sudden they say, I'm able to do this one. And changes in our intellectual capacities improve, get better. We become better learners when we provide good experiences. It is a muscle. As we go to gym to improve our skills in our use of body parts, similarly, we get good exercises, patterns, relationships, connections, by those kinds of things. As a matter of fact, there are 7 prerequisite skills we have identified which are necessary for learning. Ability to follow directions, spatial orientation, space organization, pattern recognition, etc. Now, you know what is the best way of developing the pre-skills and cognitive skills is playing games. Once I was visiting Mozambique, and children were on the beach of a lake, and they were playing Mancala. I don't know what is the name of that game in Nigeria, but it's also called Kala and Mancala in some parts of the country. And they were playing that with the cowries and making holes on the beach. That's a wonderful game. And that teaches sequencing, that teaches patterns, that teaches subitizing. So similarly, the local games, the commercial games, toys, those are the starting point for developing the ability for learning mathematics.
Wow. Wow. That's really awesome. Yeah.
I'd like to ask a question, Professor. You mentioned acquired dyscalculia and, of course, the actual dyscalculia. Now, how easy is it to differentiate between the acquired dyscalculia and the actual dyscalculia? Because a lot of times, I know there are children that have dyscalculia. How do we diagnose, and how are parents, because a lot of people, either we live in denial or people don't just want to admit, what are the signs as a parent or as a teacher or a caregiver, if someone has dyscalculia, not the acquired one this time, but medical or the actual dyscalculia? What are the signs?
There are 3 elements which are related to dyscalculia. One is difficulty in conceptualizing number. Number 2, number relationships. Number 3, outcomes of numerical operations. What do I expect as the answer? These are the 3 characteristics which are related to dyscalculia, and therefore they are related to acquired dyscalculia also. So I may have these things because there might be innate factors, such as some soft neurological signs or visual perceptual deficit, or some cognitive issues. So those might be the causes of that. I want to give you an analogy. A doctor has 3 roles. First one is to make sure that his patients, first thing, the patient itself is a negative term, that the person he works with are healthy. That means he practices preventive medicine. He says, this is a good nutrition, this is the good exercise, live this way. That means he or she gives good advice to live better. That's called preventive medicine. Similarly, we have preventive teaching. How do we teach effectively so that the children do not feel defeated by mathematics? Second role of a doctor is that if suppose there is some temporary disease, I got temperature or I got an infection, and then he gives a medicine, that means a way of removing it. And the third is, if there is a chronic disease, how to manage that so that in spite of that chronic disease, I'm able to function. There are people who have diabetes, but they manage it, lifestyle and all of that, and they are able to live well. Similarly, many other things. So teacher also has 3 roles. Parent also has 3 roles. First is preventive teaching. Second is management of the current learning. And if there's some setback, some difficulty in long division, how to deal with that long division or how to deal with that fraction and get rid of that. That means give good strategies. And third, suppose there are some limitations, how do we use the strength part of the child's abilities so that we are able to manage that limitation? So the teaching has to have these 3 components: preventive and taking care of the problems which come into play. The other day, the child says, oh, I cannot do algebra. I was working with this middle school student. These variables don't make any sense to me. I said, really? Tell me, I want to add, he said, these negative positive numbers really make my life difficult. I said, really? So let's look at this one. What is this number? Oh, she said, 8. What is this number? 8. I said, but they are different colors. I'm going to call this as positive. This one is negative. The black one has positive 8, and the red one has negative 8. So can you tell me what two negative numbers make 8? And she said, -5 and -3. I see it red. There are 5 reds and there are 3 reds. And there are 6 reds and 2 reds. And there are 7 reds and 1 red. He said, oh, so -5 and -3 is 8. -6 and -2 is 8. -7 and -1 is 8. And similarly, and so on. So she said, also the negative positive numbers is not a big deal. So if we have effective materials, effective way of presenting them, effective of reaching the child, many of the problems will not happen. And if they happen, bring good method, good strategies to allay the fear of learning in that child's mind. And the child who was afraid of negative and positive numbers 15 minutes ago, now was able to say, can we play a game? I said, actually, I was planning to play a game. And then we played a game with the cards, what I call as integer game. In integer game, we are adding and subtracting and multiplying and dividing integers. That means negative and positive numbers. So now, when I'm working with a student in middle school and they are having difficulty with negative and positive numbers, we play an integer game for about 15 minutes. And then we do the formal mathematics. And when she has a difficulty, I go back to the cards and work it out. So find ways of creating a positive attitude towards mathematics.
Yeah.
Yeah. Hello, Mr. Kide, I have a question here.
Okay.
So, Professor.
Yes.
Yeah.
Okay. Okay.
All right, Professor, thanks a lot. This is very insightful. Yeah, really learning a lot. Just a question here. You know the 9 areas of intelligence that is now propagated? The 9 areas of intelligence.
Yeah.
Yes, you know, mathematical intelligence is one of them. So what you are saying now, is it that every other areas of intelligence can actually learn the mathematical intelligence? Is it,
okay.
I want to, because sometimes, yeah.
Okay, stay there. Don't go away, okay? I was in a conference with Howard Gardner, you know, the originator of multiple intelligences. And he was a keynote speaker and I was a second fiddle. You know what a second fiddle is? So when my turn came, I said to the audience, several thousand people, I said, I'd like you to imagine when I say this word, this particular word problem. And I said, I want you to think of a child has a bag of sweets and there are 56 of them in the bag. And he wants to distribute these to 8 children. What will be the share of each child? Now, the people say, oh, that's very easy. It's very simple, you know, 1 for you, 1 for you, 1 for you, 1 for you. Somebody said, I'm going to say, well, I already know the tables, and therefore I'm going to give that many, 7 to each one. I said, good. So that was a simple one. Now I said, I want you to picture when I said the word problem, and at that time, you were saying, oh, word problem. He's going to ask one more word problem. So right away, I was texting their linguistic intelligence. And I said, I'm going to change a problem. And here is the problem. That was easy one. That was a warm-up. I have a rectangle whose length is 3 more than the width. And the perimeter is 72 centimeters. What is the length and what is the width? And all of a sudden, you should see the faces. Here we go, this problem. So I said, now think about that problem and see what happens to it. So I asked, and here are the answers from the audience. One of them said, as soon as you gave me this problem, I said, word problems are difficult for me. That is called invoking emotional intelligence. That means the person has already identified that it's going to be a difficult problem. Somebody said, I thought of a rectangle, which is long and wide. And I said it has to be longer because it's 3 more than the width. See, that person is using spatial intelligence. The other one said, I looked for the formula for the area or the perimeter of this rectangle. And therefore, that person is thinking of mathematical intelligence as seen as a procedure, not as a concept, not as a language. You can see that we attack a problem according to what is the dominant part. But mathematics is the only field in which all the intelligences are used: linguistic intelligence, spatial intelligence, emotional intelligence, as a matter of fact, intrapersonal intelligence, interpersonal intelligence. So mathematics is an integrated science. As a matter of fact, language, music, and mathematics are the only 3 things in which all multiple intelligences are used: language, any language learning, music, and mathematics. These are the 3 areas where the whole brain is being used at one time. And therefore, it is not something, as people will say, oh, I'm a left hemispheric person, therefore I'm good at math. I'm a right hemispheric person, therefore I'm not good at math. When I go to the parties and they ask, what do you do for living? And even when I was president of a university, I'll say I teach mathematics. And they will say, oh, well, I was never good at mathematics. I'm a creative person. I'm an interesting person. I'm a right hemisphere person. As if a mathematician cannot be creative, mathematician cannot be interesting, mathematician cannot be any other thing except dealing with numbers. So we have created this image of mathematics by which mothers, fathers, older brothers, older sisters convey to younger ones that math is difficult. We need to have positive experiences given to children. When children are successful, they will welcome mathematics. When they are not successful, they will hate mathematics.
Wow, interesting. Interesting. So I don't know if anybody have more questions for Prof here, because it's very insightful. I'm just trying to take in everything Prof is saying, and I must say there's a lot to gain from Prof. Mr. Kiduna here says effective materials, effective instructions, and strategies can prevent the difficulties in learning mathematics. And he totally agrees with Prof. That is one of our viewers. So effective materials, I know you've mentioned some of the cards and everything. What are the simple materials around the home, around the school? Or what are the materials that a school cannot do without when teaching mathematics? I don't know. Sanjay, can you approach that question?
I will answer this first and then I'll leave because I need to go. You see, if you want to have a good hospital in your town, do you think you are going to use the local materials only for surgery? Are you going to use the local materials only for getting people well? You want to take advantage of the latest science and you will make effort to make that hospital as good as possible. So yes, we should use the local materials, but at the same time, one should also look for efficient materials which may not be local.
Okay.
And with that, I will say thank you for inviting me, and visit my web or my blog on my website, and you will see lots of articles relating to these ideas. And
Awesome.
you are in good hands. Sanjay will fill you in all the other questions you might have.
Yeah, before you go, Prof, before you go, we did a sort of survey, and there are some teachers who are willing, to be under the mentorship of your center. I know you're very busy, but I know you have those who have worked with you, and they've indicated they want to be under the mentorship, of your team. And I don't know what a word you can say to them, and when that can begin, sir.
Well, as a matter of fact, Sanjay and I are planning a series of webinars starting from children age 3 to parents, teachers, and we will be very happy to work with teachers and parents because I really want mathematics to be the new literacy. Numeracy is new literacy. Earlier, literacy, the people with literacy ruled the world, and now it's numeracy. So I want access to numeracy for all children, so that they can decide what field they want to go. No door should be closed to children, whether it is science or STEM fields or whatever they want to. They should not feel like I cannot go there because I don't have math. So that should be their choice. If they want to be an artist, be an artist. But don't say I want to be an artist because I can't do math. It should be that I want to do artist, but I'm good at math. That's the idea.
Exactly.
Yeah.
Well
Okay.
done.
Thank you very much.
Thank you so much, Professor.
Yeah.
Thank you for taking out time in your busy schedule to be with us. We really, really appreciate you.
Thank you.
We said we will be visiting your blog, and I'll be sharing it on all the platforms so that people can see the great work that you're doing. We're going to be advertising the program you're having with the children so that parents can also subscribe for this program for their children. And I think it's going to make a huge difference, to the way they perceive mathematics and the way they approach mathematics. So thank you very much. And because we're going to be rounding up now, I just want to take a last word from you and a last word from Sejan before we round up, and we can, go back and reflect on what you have said and how to use this forward.
Thank you.
Yes. So CJ, any last word from you?
Yeah, okay. Am I audible now? Because I sometimes.
Yes, you're audible.
Okay. So, as Professor Sharma has already shared about the blog, we also have an Instagram channel where there are teaching videos by Professor Sharma. So it's a treat to watch them. And there are other videos where we are teaching children. So you can also access that. That's one. And also, you asked about materials. So Professor Sharma has materials already in US, and we are also getting them done from India. So we hope that we can actually share those materials. For example, the cards that Professor Sharma showed. So we have added new designs to those cards. There are many more designs that we have added. Uh, and new booklets also for parents, educators, so that they can actually see materials in itself will not be complete unless there are effective strategies to use them. So we are helping both the ways, that providing access to good material, also at the same time providing access to how to even use it, and even having videos and videotapes of how they have been used with children, so that parents, educators can actually see how effectively we can use them, because that is going to change the way we look at math education, and
Wow.
that is our aim and vision. So you can note down, even viewers can note down our Instagram channel. That's Math for All official, Math for All official. Maybe you can share in the link. And we have posted many videos there where Professor Sharma is also guiding parents, and we keep uploading. Every single day we are trying to upload videos of some concept or the other, so that teachers can actually have access to that.
Lovely. Thank you so much, CJ. We really appreciate. And like I said earlier, we are going to go into getting some teachers to be mentored by you and to do the training. So we'll try and get all the teachers who have indicated interest, and we'll put a date down so that they can be mentored by you and Prof and your team. I think it will be very helpful in helping them approach mathematics, even as schools are beginning to open up in Nigeria. So thank you very much. I want to have
Thank you.
another word from Mrs. Okide. You want to say something, Mrs. Okide? You're muted, Mrs. Okide.
Thank you very much, Miss David. This is really very, and thank you to Professor. I know he's left now. Thank you to Mrs. Sanjay. This is very insightful. This is just, I feel like this is just the tip of the iceberg. More things are in the works for teachers, parents, and children, like he said. So we're looking forward to that. We're looking forward to getting more of this insightful sessions. Thank you very much.
Thank you.
Thank you
I would
so
like
much.
a word also from Mr. David, so that you tell us any word for us and what we've gotten from today's serve. Hi,
Wow, really, let me thank everyone, Professor Sanji and Misokide, yourself also, and everyone that has contributed. Really, this is very insightful. One of the take home for me is the same way we lay the foundation for language for children, we should find a way to create a foundation, something for numeracy at home, a culture for that. And also something that Professor said, which Ms. Modupe also has commented on, language, music, and maths. These are the three areas that the brain is always working on. So we can actually do well in those three aspects of life. So thank you for organizing this. This is, I think the word should spread out more, let more people connect. I've been sharing here. Thank you all.
Yeah, thank you, everyone. Mr. Kiduna here is saying, thank you, Professor, for the thought-provoking insights. Thank you, Ms. Davis, for organizing this brilliant idea. Thank you, Mr. CJ, because you have done an amazing work to put this together. We appreciate you, and we thank you for all that you're doing. This is going to be on our pages so that we can always view it and look at it again. It is on YouTube and it's going to be on Facebook for a while so that we can always look at it. And then as soon as the training is ready, please let us know so that we can organize for the teachers here to attend. Thank you very much. We do appreciate you and do have an inspired day. Thank you. I'm just going to have video again to remind us of what we started with when we started today about why mathematics is very important. Thank you, viewers, everybody who has come live with us on every platform. We appreciate you. Professor was here and CJ has been here. They've thrown lots of light. I want you to go back and watch this video over and over again because it makes a lot of sense and there's a lot to gain from it. Thank you for joining us, and very soon we'll be announcing the training with Professor and his team, and I hope you get yourself registered for that.
Have you ever dreamed about becoming a doctor,
firefighter, a veterinarian, a police officer, a scientist, an engineer, an artist, an astronaut, a pilot, a teacher,
or a lawyer when you grow up? But sometimes you wonder, why do I have to learn math at a school? If so, this video is for you. Hi, I'm Miss Marilu, and this is Mathematicians in Action. The purpose of learning math is not just to pass a test to move to the next grade level. For sure, it's not to make your day harder or boring at school. The reality is that math is essential to understanding the world around us. And we need math to successfully accomplish even the most basic tasks in our everyday life. And did you know that most professions use math to successfully accomplish their job? For example, numbers provide an abundance of information for medical professionals like doctors, nurses, and veterinarians. They're constantly using math to write prescriptions or to administer the right amount of medication. Police officers also use math in many ways. A few examples are when they have to analyze traffic accidents to determine the cause of the accident and the cause of victims' injuries. They also need math to write tickets. For example, in some places, the faster a person drives, the more the ticket will be if they get caught. And this is determined by using a mathematical formula. Another example are firefighters. They use math to calculate the nozzle pressure and how much water they will need to put out the fire. Scientists are always using math. Any other science like biology, chemistry, psychology, geology, and physics relies on graph, statistics, and mathematical calculations. Hi! Did you also know that pilots and astronauts are constantly solving mathematical equations to pilot the craft? And these are just a few examples. The truth is that learning and practicing math train our brains to think logically, to recognize patterns, to identify and state a problem clearly, and to find ways to solve the problem. I know, learning math can be challenging sometimes, but remember, it gets easier with practice and a positive attitude. Thank you for watching. Don't forget to subscribe and leave your comments below. Bye bye.